Hello students, welcome to chemistry class. Today we are going to start new chapter, that is structure of the atom, and we'll discuss the following topic: charged particles in matter, Thomson's model of an atom, Rutherford's model of an atom, Bohr's model of an atom, and neutrons. Learning outcomes. After the completion of the topic, students, you will be able to: number 1, name the 3 subatomic particles of an atom, which are electron, proton and neutron. Number 2, compare the properties of electrons, protons and neutrons on the basis of their relative mass, charge and location inside the atom. Number 3, state the postulates of Thomson's model, Rutherford's model and Bohr's model of an atom. Number 4, you will be able to enlist the drawbacks of Thomson's model and Rutherford's model of an atom, means why these two models got failed. Number 5, you will be able to draw well-labeled diagrams describing various models of an atom like Thomson's, Rutherford's and Bohr's model of an atom. Students, let's firstly revise the term atom. Atoms are building blocks of all matter. An atom is defined as the smallest particle of matter which may or may not exist independently. For example, hydrogen, carbon, gold, iron, etc. If it doesn't exist independently, then atoms combine to form molecules. A major challenge before the scientists at the end of 19th century was to reveal the structure of atom as well as to explain its important properties. Many scientists worked hard and proposed many models for the atom. Students, according to John Dalton, atom is indivisible, means it cannot be divided. But on friction, that is rubbing two objects together, charges are created and that charges come from atom. It means an atom is divisible, means it can be further divided, and it consists of charged particles, namely electrons, which are negatively charged, and protons, which are positively charged. Many scientists contributed in revealing the presence of charged particles in an atom. Thomson discovered electrons, which are negatively charged particles present in the atom. He took a gas discharge tube, which is known as cathode ray tube, and on passing electric current, it makes a beam appear to move from cathode, that is negatively charged electrode, to the positive end. He named these rays as cathode rays, which consist of electrons. Then another scientist, E. Goldstein, discovered protons. He took perforated, means having holes, perforated cathode through which canal rays, that is positively charged rays which consist of protons, move and in the form of canal, and these canal rays are also known as anode rays. And he discovered existence of a positive fundamental particle called the proton. Students, E. Goldstein identified proton, discovered proton. Actually, even before the electron was identified, E. Goldstein discovered the presence of new radiations in a gas discharge tube, which ultimately led to the discovery of another subatomic particle known as proton. So, subatomic particles inside the atom are: number 1, electron, which is represented as E minus, negatively charged particle, discovered by J.J. Thomson. Next, proton, P for proton, P for positively charged particle, discovered by E. Goldstein and is represented as P plus or P. Neutron, it is denoted as N. It is neutral, means no charge, and discovered by James Chadwick. So students, here we have achieved our first learning outcome, that is now we can name subatomic particles present in an atom. Next, let's compare the properties of these subatomic particles, electrons, protons and neutrons. The first one is charge, negatively charged, positively charged, no charge, that is neutral. Number 2, location. It is located outside the nucleus. Students, nucleus is the central part of the atom, and protons are present within the nucleus and neutrons are also present within the nucleus. It means nucleus of an atom consists of protons and neutrons, and electrons are present outside the nucleus. Third, relative mass. Electrons have very less mass and it can be 1 upon 1840 or 2000 of proton. Mass of the proton is 2000 times of electron or equal to hydrogen atom, and neutrons have almost same mass as that of protons, that is equal to hydrogen atom or 2000 times of electron. Affinity. As these are negatively charged particles, so they will be attracted towards positively charged anode, and protons are positively charged, they will get attracted towards negative charge. Neutrons do not get attracted to any charged particles because these are neutral. So students, here we have achieved our second learning outcome, that is now we can compare the properties of electrons, protons and neutrons. The discovery of the two fundamental particles, namely electrons and protons inside the atoms, led to the failure of the aspect of Dalton's atomic theory. It means atom is divisible. For explaining the arrangement of electrons and protons in an atom, many scientists proposed various atomic models. J.J. Thomson, who discovered electrons, was the first one to propose a model for the structure of an atom, which is known as Thomson's model of an atom or plum pudding model. Postulates. According to him, an atom is spherical in shape. Number 2, an atom consists of a positively charged sphere and electrons are embedded in it here and there. Number 3, which is very important, the negative and the positive charges are equal in magnitude. Means an atom has equal number of electrons and protons. So the atom as a whole is electrically neutral because equal number of positively charged protons and negatively charged electrons cancel the charges of each other. This model is also known as plum pudding model because electrons were like currants or dry fruits in a spherical Christmas pudding. It has also been compared with the watermelon. The black seeds inside the watermelon are compared with electrons, and edible red part is positively charged part. Limitation. Why this model got failed? Because the results of the experiments carried out by other scientists like Rutherford could not be explained by this model. So this model got failed. So students, here we have achieved our third learning outcome, that is now you are able to state the postulates of Thomson's model of an atom. Also, you can list the drawback of or limitation of Thomson's model and draw a well-labeled diagram of Thomson's model of an atom. Next is Rutherford's gold foil alpha particle scattering experiment. Alpha particles are doubly charged helium ions with mass is equal to 4 unit. These are produced by radioactive elements which are heavy metals. He took gold foil as gold is most malleable and ductile metal and he wanted as thin a layer as possible. This model led to the discovery of nucleus, which is the central part of an atom. In his experiment, Rutherford bombarded or allowed a beam of fast moving alpha particles. Students, this is the sign of alpha. Alpha particles having positive charge to fall on the thin gold foil. He observed that number one, most of the alpha particles passed straight. Here you can see passed straight through the gold foil without any bending. Number two, some of the alpha particles were slightly deflected, means bent by the small angles, and some by large angles. Number three, very few, 1 out of 20,000 alpha particles appear to rebound, that is, they come back by the angle of 180 degree. Students, this is the diagram of Rutherford's gold foil alpha particle scattering experiment in which 3 observations have been depicted. Conclusions. Number 1. From the first observation, Rutherford concluded that most of the space inside the atom is empty. Just like on the empty road, we can move straight without any hindrance. Similarly, alpha particles were going straight because most of the space inside the atom is empty. Number 2, the positive charge of the atom occupies very little space. Number 3, all the positive charge and mass of the atom were concentrated, means present in a very small volume within the atom, which is known as nucleus. And the radius of nucleus is very, very small as compared to the size of an atom. Nucleus is positively charged. As I have already told you, it has protons and neutrons. Positive charge on the nucleus is due to protons. Next is Rutherford's model. So an atom consists of a positively charged center in an atom, which is known as nucleus, which consists of protons and neutrons, and mass of the atom is contributed mainly by the nucleus, because we have already discussed during comparison that the mass of the electron is negligible. Next is the size of the nucleus is very small, as I have already told you, compared to the size of an atom. If a football is considered as a nucleus, then complete or whole football ground is an atom. So you can well imagine. The electrons revolve around the nucleus in well-defined circular paths, which are known as orbits. So students, here we have achieved our third learning outcome, that is now you are able to state the postulates of Rutherford's model of an atom, and fifth learning outcome, that is now you can draw a well-labeled diagram showing Rutherford gold foil alpha particle scattering experiment. Let's now discuss the defects of Rutherford's model of the atom. This model could not explain stability of an atom. Students, any particle in a circular orbit would undergo acceleration, means during motion the charged particle would radiate energy, will lose energy. So the revolving electron would lose energy. You can see the arrows, and fall inside the nucleus. Then atom should collapse. But this never happens, as we all know atoms are stable. So that is why this model got failed. So here we have achieved a fourth learning outcome, that is now you are able to list the drawback of Rutherford's model of the atom. Next is Bohr's model of the atom, which is the most acceptable model. Postulates. An atom has two parts. A part, central part, which is known as nucleus, having protons and neutrons. B part, extranuclear part, which is the part outside the nucleus in which electrons revolve. Next, in an atom, the electrons revolve around the nucleus in certain fixed circular paths, which are known as orbits or shells or energy levels. These are represented by the number 1, 2, 3 or 4 or the letters K, L, M, N starting from the nucleus. Means first shell which is closest to the nucleus will be known as K shell and it has N is equal to 1, followed by L shell, M shell and N shell respectively. So the orbit for which N is equal to 1 is the lowest energy level. Next, each shell or the orbit corresponds to a fixed energy and only certain special orbits known as discrete orbits of electrons are allowed inside the atom. While moving in the discrete orbit, the electrons do not radiate, do not lose energy. But if an electron jumps from a lower to higher level, it will gain energy, and if an electron jumps from higher to lower level, it will lose energy. So this is the diagram of the Bohr's model of an atom having 4 shells. So students, here we have achieved our third learning outcome, that is now you are able to state the postulates of Bohr's model of an atom, and fifth learning outcome, that is you can draw Bohr's model of various atoms. Next is discovery of neutrons. We have discussed about neutrons in detail. Let's revise it. In 1932, James Chadwick discovered another subatomic particle which had no charge, that is, it is neutral, and a mass nearly equal to that of a proton. It was eventually named as neutron. Neutrons are present in the nucleus of all atoms except hydrogen. About this we will study in next classes. In general, a neutron is represented as N. The mass of an atom is therefore given by the sum of the masses of protons and neutrons present in the nucleus. As we all know, electrons have negligible masses. So, at the end, we have achieved all learning outcomes. Students, now you are able to, number 1, name the 3 subatomic particles present in the atom, namely electron, proton, neutron. Number 2, you can compare the properties of electrons, protons, neutrons. Number 3, you are able to state the postulates of Thomson's model, Rutherford model and Bohr's model of an atom. Number 4, you are able to list the drawbacks of Thomson's and Rutherford's model of an atom. Number 5, you are able to draw well-labeled diagrams explaining various models of an atom. I am sending you the link of assignment. Kindly solve it in your notebooks. Thank you.